listeners, to another episode of the Dark Assassins podcast, the show that dives deep into not just technology, but the concepts, software, and procedures behind it all, and explains it so simply that even your grandma can understand it. As always, I'm your host, the Dark Assassin. I hope you guys like spice because DARPA, or the U.S. Defense Advanced Research Projects Agency, just dropped quite the spicy take or idea, I guess, this week, which is essentially this idea of using AI and machine learning to convert all code written in that garbage, non-memory safe abomination known as C, and translate it into the Alpha Sigma Chad language, aka Rust. And they're calling this new tool Tractor. And of course, because this is a government agency, Tractor is of course an acronym because it has to be. And it stands for Translating All C to Rust. So yeah, they got a little, they took a few liberties there in taking a couple letters from different words in that sentence and making it acronym out of it. So I don't know if it was like is it a backronym when you take a sentence or phrase and then convert it into an acronym rather than you have a word or phrase and you want to get a sentence out of it? I forget what it is, but it looks maybe a tad forced, but it's not the best acronym, but the government loves their acronym, so of course they had to have one. So we're going to be getting into what is this Tractor tool and is there any validity to it? Is there any chance that it's going to work? So that is coming up in this episode. But first, let's get into our trivia question for the week. So in computing, the BIOS is a firmware used to provide runtime services for operating systems and programs and to perform hardware initialization during the boot process. But what does BIOS stand for? So again, what does BIOS stand for? And that is your trivia question for the week. Now, before we get into the cybersecurity tip for the week, I did want to point out that your boy got absolutely flamed and roasted this week. And specifically, there is a site that I discovered called githubroast.pages.dev. Hilarious. And essentially how the site works is it uses I'm not sure what LLM they used or whatnot, but essentially the point of this page is you give it any username for any user on GitHub and they will essentially roast that user. So naturally I had to see what it had cooking for me, and this is what it came up with. Oh, Dark Assassin 23, what a name you've chosen. Did you think it'd make you sound mysterious or edgy, or just plain painfully generic? With a whopping 6 followers, you might want to reevaluate what it means to be an elite, or what it means to be an elite in the GitHub world. Your repos are about as popular as a diet soda at a barbecue, 0 stargazers on most of them, and the few that have some don't quite scream success either. Elite encryption algorithm? More like minimal interest algorithm, and who knew a war simulator was the pinnacle of your ambition? Spoiler alert, it's not even a top-tier card game. With 37 public repos, it's shocking how you still manage to leave 0 impact. So many projects and yet so little attention. It's like you're a ghost hunting the code world. But instead of scaring people, you just confuse them. If you're trying to hide from the spotlight, mission accomplished, amigo. So that was the roast of me based on my GitHub. And I threw in some other accounts that I knew of just to kind of see what it would spit out about them, and I have to say it was quite hilarious. So it did a pretty good job. I think the one it gave for me was pretty decent. Definitely not as good as some of the other ones I've seen, but also I think fairly decent as well. So let me know what you think of that roast, or if you asked it to roast your GitHub profile. I'd also be interested to hear what it told you. So you can either leave a comment below on YouTube, or you can shoot me an email at contact@darkassassinsinc.com. But with that, let's get into this week's cybersecurity tip. This week's cybersecurity tip is pretty much one of those that anyone with a home lab can probably take and utilize. And that is to secure your switches and other devices at the hardware level. Now, if you're a home labber like me, there's a strong likelihood, I would say, that you have a network switch in your home lab infrastructure, whether that's in your rack or whether that's on a shelf somewhere. Chances are you have a switch, because if you have a home lab, there is a strong likelihood that you ran out of ports on the back of the router that either you bought or your ISP gave you, and you needed more Ethernet ports. And the way you can get more Ethernet ports is through an additional network switch. But network switches aren't just for adding more Ethernet ports. They can also give you a ton of other different features, like faster networking. They can give you other support for things like VLANs and all kinds of good stuff. But when it comes to network switches, by default, they're not exactly the most secure things in the world. And what I mean by that is, generally by default, you can plug they're essentially operating like a dummy switch. Even if they're a managed switch, they're operating like a dummy switch. And what that means is, once you plug in a device into it, it essentially gives it access to whatever network the switch is on, and you can, get access to whatever's there. So from a security perspective, I think if you listen to the podcast for long enough, you can probably see why that's maybe not necessarily the best idea. So when it comes to securing your switches, there's a couple things that you can do. One, first off, you have to have a managed switch. If you have an unmanaged switch or a dummy switch, there's really not much you can do about it. But if you have a managed switch, what you can do all kinds of different things in order to make it more secure. One of those is you can actually disable unused ports. So if you're not using, say, ports 15 to 20, you can disable those ports. So if someone were to come by and plug an unsuspecting device into your switch, they wouldn't be able to access anything because those ports are disabled. Another thing that you can also do is tie specific ports to MAC addresses. Now, this can be quite annoying at times, but again, it goes back to that principle of convenience versus security, right? If something's more convenient, it's generally speaking less secure. So, kind of the idea for this idea of tying specific MAC addresses to ports is it basically prevents someone from, knowing that, okay, there's a Ethernet port or an Ethernet cable plugged into this jack, so if I unplug that cable and plug mine in, I can then get access. So this basically helps prevent the use case where you took the effort to disable the unused ports, but someone can't just come along and unplug one of the devices in the used ports and then gain access to your network. So tying specific ports to MAC addresses is another way that you can secure your switch. And as we also kind of touched on, VLANs is another one, or virtual local area networks. And one thing that switches can also do is they can have, inner VLAN routing, or essentially allow some VLANs to talk to other VLANs, or not allow some VLANs to talk to others through things like access control lists or ACLs. And these are really cool because you can essentially create, your own virtual networks essentially on the switch. So if you say plug into a select 3 ports, you're on essentially this network, but if you plug into these other 3 ports, you're on a completely different network, and then you can basically make rules through the access control list on whether those 2 networks can talk to each other or they can't. So this is fantastic if you want to deal with any kind of like IoT devices or Internet of Things devices that you don't necessarily trust being on your network. You can essentially isolate them and secure the rest of your network from them. The other thing that VLANs can basically allow you to do is in addition to securing IoT devices, you can also create like fully isolated networks that maybe don't even have access to the internet in general, but you want to be able to talk locally to one another. So a use case for this could be IoT devices, sure, but also if you're dealing with any kind of let's just say sketchy software, or maybe you're playing around with a pen testing lab, or playing around with malware to do some kind of reverse engineering or exploratory stuff to see how malware works, kind of setting up a hacker type lab for that. Probably best to make sure that stays isolated. Now, one thing that, depending on what malware you're playing with, some malware can detect things like being within virtual machines, not having access to the internet. So in order to spoof that, you can essentially create like a fake internet, and one way you could do that is through like a VLAN or something, but ensure that that VLAN is isolated and nothing can get in or out of that VLAN, so you can essentially ensure everything kind of stays contained. So that's another fantastic use for VLANs as well. But also in regards to switches, there's other things that you have to keep in mind. Now, we've talked a few different times on the podcast of vulnerabilities that have come up on switches and routers in regards to things like their access, right? Like the web console having some kind of vulnerability in it, or something like that. So one thing you also want to check is if you have a managed switch, what kind of ways can you access that management console? Does it have a web console? Does it have an SSH connection that you can connect into? Does it have a serial connection you can plug right into? And if your answer is yes for any of those questions, what kind of authentication is needed in order to access those? So those are some things that you also want to be looking out for on your switches. But in addition to switches, there's also hardware devices as well. So depending on your hardware device, depending on like the computer, you can enable and disable certain ports. Like for instance, there are some instances in BIOSes where you can enable or disable USB ports, so you can basically ensure that no one's coming along and plugging in a rogue USB into your device and infecting it with malware. Another thing that you can also do with this too is you can enable things like Secure Boot to make sure that someone couldn't be, loading some kind of device that they shouldn't be, or loading some kind of operating system that they shouldn't. And really the whole point of all of these little things is, of course, none of these things is going to keep you safe from a potential attack, right? Because there is no silver bullet when it comes to cybersecurity, but all of these are essentially different layers you can add to your Swiss cheese, like I like to call it, for your security, layers, right? So yes, no layer of Swiss cheese is perfect. Every layer of Swiss cheese has holes in it. But if you layer enough layers of Swiss cheese on top of one another, it becomes a lot harder and harder to get through all those layers of cheese and navigate through all the holes in order to break through. Not saying it can't be done, but it's a lot harder if you have multiple of those layers stacked on top of one another. So that is your cybersecurity tip for the week. And before we get into the nerdy things, of course, if you saw the news about Google this week, of course you know that I had to talk about it. And I guess it's probably not a surprise that I'm talking about this, because if you've listened to the podcast for long enough, you're probably aware of the fact that I am not exactly a fan of Google for a various number of reasons, but suffice it to say, I'm not a big Google fan. And it's kind of, to me anyway, it's kind of funny when I hear people talking about how, oh, all the issues that have been happening with Google, like Google search is not being good anymore because of all the ads and AI that's being thrown into it, or any other issues with Google or Google services. And I'm just over here like, I have no idea what you guys are talking about or complaining about, because I haven't used Google in I don't know how long. I don't use any of their services on a regular basis. I don't use things like Google Docs or Sheets or any of their Office suite. I don't use their search engine. I don't even really use Google Drive at all. Like, I don't really use any of that stuff. So it's honestly quite nice. And I haven't really missed it at all. So if you are still using Google, I would kind of implore you to maybe not make the hard switch, but like maybe give it like a week or like a couple days or something where you just force yourself not to use Google and just kind of see what your experience is like. And if you don't like it, sure, go back. But anyway, the reason I bring this up is the big news this week relating to Google is the fact that Google search has been found to be a monopoly in a court fight or a legal battle or whatever you want to call it. A judge has ruled that Google search is a monopoly. Now, before you go and take your victory lap, in all reality, this doesn't mean anything, at least not yet, because there is going to be a separate trial in the future that will take place in order to determine what the penalty will be for Google being found to be a monopoly in the search realm. So in regards to this, the judge, I guess, overseeing the case said, quote, "The trial evidence firmly established that Google's monopoly power maintained by the exclusive distribution agreements has enabled Google to increase text ad prices without any meaningful competitive constraint." And the judge went on to say, quote, "Unconstrained price increases have fueled Google's dramatic revenue growth and allowed it to maintain a high and remarkably stable operating profits," end quote. Now, the specific exclusive distribution agreements that the judge is referring to here, if you're not aware, Google pays multiple companies to essentially be the default search engine. So some of the more notable ones are companies like Apple. It pays Apple, I think it's something like $20 billion. That's billion with a B, by the way, as in Bravo. $20 billion to be the default search engine on all Apple devices. And in addition to that, I believe Apple also gets some percentage of the cut of the ad revenue that Google generates through all those Apple devices. And then, of course, there's also Mozilla. So through the Firefox browser, Google pays them in order to be the default search engine. So basically, deals like that is what the judge is referring to when they mention exclusive distribution agreements. So the judge also ruled that Google, with about 90% market share, has monopoly power in both general search and general search text ads, which I think is pretty clear to anyone that has been asking anyone what search engine they use in the past, I don't know, like 15 years or so. And it's even gotten to the point where Google has kind of become a verb in a way, kind of like Kleenex has become kind of Kleenex is technically a brand, but rather than saying like getting a tissue or something, like, oh, just go grab a Kleenex. Same thing with Xerox, and Google has kind of found its way into that as well, where it's just become so synonymous with the idea of searching something online. People just say, oh yeah, just go Google it. Mainly, I think, because a lot of people do actually end up using Google to Google it, as seen by their market share. But it's kind of become this, verb to search something on the internet. Now, I'm not saying I'm perfect at this, but I have tried my hardest to catch myself whenever specifically on the podcast, but also just in general, when I'm referring to people to like look something up online, to restrained from saying Google it and say like, just, look it up or search it online or something like that, and not say Google. Partly to not encourage people to use Google because, like I said, I'm not a big fan of it. But also, yeah, I guess that's mainly it. But yeah, so it'll be interesting to follow this story to see what the penalty's potentially going to be. Although with how, court cases generally go, and this having to be a separate trial, I'm not entirely sure how long it'll be until we find out what the penalty is. But it should be something interesting to follow. And with that, let's get into what nerdy stuff have I been up to this week. Now, I gotta admit, it was quite good this week to get back into working on my video game, which I guess working on my video game is rather a loose definition of what I did this week, but I'm just gonna roll with it. Because what I did was added automated test cases. So I've had test cases before, of course, because I've been doing tons of manual testing. But one thing that I wanted to do was incorporate actually building the code and doing some kind of running of it to test it as part of my CI/CD, or continuous integration and deployment pipeline. And because currently all the pipeline does is it generates the documentation for the project and then publishes it to a Docker container that I can access on my home network, which is cool. But it doesn't really do anything in addition to that. So I kind of wanted to add more use cases to it. And one of them I thought would be cool is to have an automated test suite, because if you're ever working in any kind of a DevOps environment, if you're doing it properly, part of your DevOps pipeline should be some kind of automated testing before your code actually gets, packaged and deployed anywhere. Because you want to be sure you didn't push some change that ended up breaking something. And one way to do that is to run it through some automated tests to ensure it's actually doing what it's supposed to. Now, of course, that comes with the caveat of you have to ensure your automated tests are robust enough and all-encompassing, which we're going to get more into that, a little bit of foreshadowing, if you will. But you want to make sure that your test coverage actually covers, either the vast majority, if not the entirety of the code base, and checks for things like edge cases, malformed user input, all these kinds of things, to make sure that your code base is robust enough so when it gets deployed out into production, it's solid and not a complete and buggy mess. Now, some people argue that the best place to test your code is in production. Because but also if you are going to test your code in production, it's best to, of course, push on a Friday, or like a Thursday evening. CrowdStrike did a good job demonstrating why that's a brilliant idea. But you want to make sure. But like, in all seriousness, though, you want to make sure that you are adequately testing your code before it goes out into production. Now, of course, before you even push any changes, you want to be doing your due diligence to ensure that you test the code thoroughly and test your changes. But any software developer knows it's quite common to be working on a change somewhere. You test those changes work, but then for some other reason you ended up breaking something else and code elsewhere isn't working, and that might not have been something you even thought to test because your code didn't directly interact with that other portion of the code, so you didn't bother running the tests, and then you push to production, and then lo and behold you have a bug that you introduced because you didn't test it. So having those automated tests that ensure that full code coverage is pretty crucial. So which is part of the reason why I wanted to incorporate that as part of my build pipeline. Now, in order to do that, I need automated tests. So essentially this week I was reworking my build system, working the make file in order to add support for that. So now I have support so I can run a make command to essentially build an automated test version that'll essentially run through a suite of automated tests. Currently, I've only ported over 3 tests, which arguably isn't very many, but of course you got to start somewhere. So continuing to work those ports in and basically just add to the automated test suite. But since I kind of have at least this baseline, my next goal is to actually implement it into the CI/CD pipeline and actually have the pipeline build the code, build the test version of the code, run the automated tests, and then assuming it passes, continue on with the rest of the build and whatnot. So that's the goal for the future. But in addition to that, I also kind of had this idea of a new thing I can do, which is a way to test for memory leaks. Now, if you've listened to the podcast for a while, probably about a year ago or so, I went on a crusade of trying to squash and get rid of all of the memory leaks that were found in my video game, because I, of course, am writing this video game in C++, and as we've talked about on the podcast before, C++ is not a memory-safe language, which means you have to manage all the memory yourself, which means you can have things like memory leaks, memory errors, and all that good stuff, which before I was... before I saw the light, essentially, of like code analyzers and memory analyzers and tools like Valgrind, for instance, I didn't bother to check any of that stuff. And boy, was it a grind to remove all of those memory leaks and memory errors riddled throughout the code base, which is why it's good to ensure you're testing that stuff frequently and often, so you don't have to spend, over a month or possibly more than that tracking down memory leaks and other various memory errors in your code base. It's a lot easier to do it in the beginning than to do it retroactively. So one thing I kind of wanted to do as part of this automated test suite is be able to kind of get some kind of like Valgrind-like analysis of memory leaks, but be able to do it in an automated test suite scenario without having to specifically use Valgrind, because one thing I kind of want to try to do is, if memory leaks exist in the code base, essentially, error out or throw some kind of error to essentially force the build pipeline to fail. But one thing with Valgrind is, even if the code has memory leaks, it'll essentially still return whatever the program returns. So if the program returns 0, or essentially everything went okay, Valgrind will return 0 as well, even if there are memory leaks. So essentially what I wanted to do is write a memory analyzer, if you will, and embed it into the code itself. Now, how on earth am I going to do that? Well, I'm not going to say it's simple, because that could be off-putting to some people, but it's not as complicated as you might expect when you initially think about it. Because when you think about you're essentially creating your own memory allocator, in essence, is what you're trying to do here, in order to adequately track all of the memory that your program allocates and deallocates through the course of its runtime. if you're doing it internally, you essentially need to have your own memory allocator. Now, of course, I didn't write my own memory allocator because that would be its own project in and of itself. But what I did is I essentially created pound defines to essentially overwrite the built-in memory allocators to essentially be a wrapper for them. And currently I only have this for the C allocators. I haven't done a operator overload for new and delete yet, although I do plan on doing that eventually. But for the C variants of the allocators, like your malloc, your calloc, your realloc, and your free, what I did was I created pound defines for each one of those four and then created separate functions that essentially wrap around those. So, for instance, the malloc function, the version I created, essentially takes in a size just like malloc does. And then in addition to calling malloc to allocate the memory, it also takes the pointer that was returned from malloc, puts it into a dictionary or a map, and then essentially stores that. And then whenever you call free, it will then, because it's a map, it can just index directly into the map and then remove that element from the map. And then you can easily check at the end of your program's runtime if there's any elements in the map, you had a memory leak somewhere or you didn't free all of your memory. So basically a quick and easy way to check for memory leaks. So that is something I plan to integrate into this automated test suite. And then basically, once the automated tests have finished, I can basically check to see if there's any memory still allocated. And if there is, essentially return a non-zero value. And then that can signal to the CI/CD pipeline that something failed due to a memory error or in a failed test case, because that's something I also plan to do is if not all the test case pass, so for instance, say currently there's 3, if only 2 out of the 3 pass, essentially return a non-zero value saying that the program didn't finish as expected, it didn't complete properly because all the test case didn't pass. So same thing with memory. There was a memory leak somewhere, the code's not ready for production essentially. So that's something I plan to integrate into that in order to try to add some more robustness and checking to the code. But also, it'll be nice to be able to do that and kind of get a picture of what's going on in the code once graphics really become more of a staple. Because one thing, as much as I love using Valgrind to check for memory leaks and memory issues, when using it with anything graphics related, it is painfully slow, which is to be expected, and it's one of the known limitations with Valgrind, which is why sometimes you'll hear recommended that you use like an address sanitizer instead, because it's faster than using Valgrind. The only issue is address sanitizers, there's more steps involved, I found, in order to get them up and running, because you essentially have to compile all of your code with specific flags in order for the address sanitization to work, for one thing, and two, it's very platform specific. Fair enough, Valgrind's also pretty platform specific, but the thing with Valgrind though is you don't need like specific flags to compile your program and all its dependencies with in order to actually properly use, which is one of the reasons why I've kind of gravitated more towards Valgrind than like address sanitizers. But where the heck was I going with this? Oh yeah, we were talking about writing a custom memory allocator. But also, when it comes to doing a implementation like this of using your own custom memory allocator, that's mainly the purpose of what they're used for, is for debugging purposes. You don't want to be using these in production. And it's not all that difficult to implement that. Essentially what you can do is you can just do like an if-def check to see if you are running in, say, a debug mode or a testing mode or something like that. And if you are, then include essentially your redefinitions of the malloc, calloc, realloc, new, delete, all that stuff. Otherwise, if you're running a release build, don't do that, because of course all this additional overhead for the malloc calls, right, like managing a map of all the pointers and how much memory they're taking up, and then once you're freeing them, removing them, granted, it's probably not a ton, but also you have additional memory overhead and performance overhead of, additional steps. So definitely something you don't want to do in production. But again, if you're using something like C++, you can do things like if-def checks, or essentially compiler checks at compile time, whether or not those should be included or not. So hopefully that was kind of helpful or maybe informative to someone. I don't know. But now let's get into the real main portion of the episode, which is DARPA's tractor. Which, when you say it like that, it almost sounds kind of cool, I guess. But as we stated at the top, Tractor, or Translating All C to Rust, is DARPA's programmatic code conversion vehicle that they plan to develop that will use machine learning tools that can automate the conversion of legacy C code into Rust. And I guess the government didn't want to be left out of the AI bandwagon before the AI bubble crashes and all that. They wanted to get in on it before it goes down, I guess. But, what's funny is, literally this week, I had a conversation with a guy where we kind of discussed something different, something similar, along the lines of, AI, being like way overhyped. Essentially how the conversation went was, yeah, AI is really cool and it can do some cool things. And if you have no idea what you're asking it, it can sound really intelligent. But the problem is, all you have to do is ask it something that you're deeply knowledgeable on, or have like a firm, foundational understanding of, and the facade of it being this, all-knowing, super intelligent thing completely and immediately wears off. Specifically for me anyway, when I ask it anything like programming or coding, or, anything like IT related, something I have a strong foundational background in, I can instantly see all kinds of holes and issues with it, which makes sense because at the end of the day, literally all these things are is, text prediction machines. All they do is predict through some kind of mathematical algorithm, a bunch of calculus and all that jazz, what the most likely or probabilistic thing to come next in a sequence is. That's literally all it's doing, at least for the large language models that generate text and stuff. So specifically when it comes to AI code generation, which is essentially what this tractor is planning to do, it's a little bit different, I guess, in the sense that it's translating code rather than generating code, but it's still, at the end of the day, generating code. And as someone that has played around and experimented with using AI to generate code, I feel like this is kind of something in my wheelhouse. I've had experience with it, and as someone that's written, software professionally, it's kind of I'm not a fan. I'm not sold. Is kind of the spoiler of what the conclusion's going to be. But I've of course, like most people out there, I've played around with these AI tools. Like most software developers, I've experimented with it to see what kind of code it can generate. And in all honesty, every time I've experimented with trying to use AI to generate and write code, I honestly have never been all that impressed, because the vast majority of the time, it never, like, there might have been like one or two instances where it worked, but the vast majority of the time, it either has compilation errors or logic errors or some other kind of issue with it that cause it not to work as expected without some serious modifications. So rarely does it ever work. And to be honest, if we're being like completely honest here, I've had better luck copying and pasting code from Stack Overflow and getting it to work immediately than prompting an AI for, some kind of code snippet and then pasting it in, which I don't know if that's more sad on Stack Overflow or the AI's part, but it's just some anecdotal point that I thought would be worth bringing up. Anyway, getting back into the article here, the reason why they, of course, they being DARPA, wanted to push for this, converting the C code and theoretically C++ as well, over to Rust, is because the government recently has been pushing to switch to memory safe coding languages. Now, we talked, maybe it was like a couple months ago or something, I think it was the Biden administration came out with like some executive order basically encouraging, the industry to switch from, memory unsafe languages like C and C++ to memory safe languages like Rust and Swift and Go and those kinds of languages. So the reason for this is for wanting to switch to memory safe coding languages is there was also a report that came out, I think maybe around the same time, maybe a little before, that was something to the effect of, I think that Google and Microsoft found that 70% of all computer bugs were due to memory safety issues. So essentially, if you can convert all of all the code that's written in these memory unsafe languages and essentially eliminate 70% of all the bugs in software, that would be a huge deal. And I honestly can't emphasize how big of a deal that would be and how frankly amazing it would be. So the premise of using memory safe languages and eliminating a vast majority of the code vulnerabilities is a fantastic thing. So while I'm essentially going to be bad-mouthing and kind of talking against why this isn't necessarily a great idea, I also want it to be quite clear that I'm not saying that, these bugs should still exist. Because if you can eliminate 70% of all bugs in software, I mean, that is absolutely huge. So anyway, kind of getting back to the premise here of translating code from one language to another. Anyone that's had to translate code from one language to another knows it's not necessarily a hard thing to do. I mean, it partly depends on what languages you're going from, like what language you're translating from to what language you're translating to. So of course there's some caveats there, but it's not necessarily hard per se, but it's time consuming. And as someone that literally just spent the past few weeks translating their encryption algorithm from both, well, technically I was mainly referencing the C version, but so technically translating C code into Swift code, it wasn't hard for me to do anyway, but it was time consuming. I mean, we talked how many episodes in a row did we have where the nerdy things segment was literally just me talking about, those code updates that I was making. I think it was like at least 3 weeks. Now, granted, this is me, essentially doing this in my spare time, not like this is the only thing I'm doing and it's my day job, full time. So granted, if you were working at translating code full time, it's a little bit of a different use case, but, the point still stands that translating code from one language to another is time consuming. And depending on your skill level, can also be quite difficult, and also depending on the programming language too. But specifically, I want to focus on it's time consuming, right? Because you essentially have to rewrite the entire code base, which... yeah, it probably took longer to write the original code base, but depending on how many lines of code you have, you got to translate all those lines of code into another language, which isn't exactly something that's fast to do. Now, of course, if you're using some automated tool or AI, you could, of course, speed that process up. But there are still risks and issues that you run into, even if you are using, some kind of automated tool or AI or something like that. Some of the most common ones are, one, adding new bugs into your new translated code, because whenever you're translating code from one language to another, it's just like if you're, translating English or, any kind of language from one language to another, right? Like, how you say something in English doesn't translate perfectly into, say, Spanish, right? Like, the order of your verbs and your nouns and whatnot aren't in the same order. So while in English you might say something one way, if you said it verbatim that exact way in Spanish, for instance, it's completely backwards and doesn't make sense. I mean, if you said that to like a native Spanish speaker, they probably could understand what you were getting at. but they could easily tell that your grammar is way off, right? So it's the same thing when you're translating from one programming language to another. You're going to run into cases where you might, add in and add new bugs to the code base that weren't there before. And also, depending on how you're copying it, you might just blindly copy existing bugs from the old code base into the new one, which also is kind of an issue. So if you plan to translate an entire code base from one language to another, especially if you're translating like mission critical code, you better be sure that you have a lot, and I mean a lot, of test cases that cover your entire code base to ensure you didn't mess anything up somewhere. Because kind of like we mentioned not too long ago with the CI/CD pipeline and ensuring you have, that full test coverage, this is a perfect example of why you need that full test coverage. Because if you're essentially completely redoing a code base, you need to verify without a shadow of a doubt that this code base performs exactly like the old one, if not better. Otherwise, you're essentially wasted your time, because if you convert the old code base into a new one, but you end up adding all kinds of new bugs and adding legacy bugs, I mean, you essentially just made a worse product. So essentially, the only way for this to have a benefit is if you can get a perfect one-to-one where you don't introduce any new bugs to the new version and the new version is just as reliable and rock solid as the old one. But then again, some would make the argument, then why did you even bother switching your code over, because you just invested all this time to essentially get the same exact outcome? Now, of course, we can also go back to that 70% of bugs are memory safety issues. So if you converted your code base, say, from C to, in this case, Rust, you could make that argument that it was a net benefit, that even though the code performs the same, there's no speed up in performance, and it's just as resilient as the old C version, but there's now zero chance for memory issues. You could potentially still chalk that up as a win, but it also still goes without saying all the effort and time that goes into translating a code base like that. Now, one thing that actually can be beneficial to translating code from one language to another, and something that I also kind of discovered in my history of doing this, is you can actually catch bugs this way and catch like various types of errors. Because if you're translating code correctly, you're not just reading from one language and writing it in another language. You have to essentially kind of go through and analyze what the functions are doing, what the lines of code are doing, in order to properly translate it to the other language, right? If we go back to human language, right? In order to properly translate a sentence from French to English, you have to understand the full context of the sentence in order to properly translate it, right? Like you can't, like sure you can take individual words and translate them, but your grammar is going to be messed up, right? Your sentence structure is not going to be correct. So it's the same thing when it comes to translating programming languages. You can't just translate the words verbatim, obviously. You have to kind of understand the context of what the function's doing and translate that accordingly into the new language. Like, for instance, if you're, this is kind of backwards in this use case, but if you're, say, translating from, say, Python to C, there's a lot of things in Python that you don't have to worry about that you do in C, right? Like you don't have to worry about allocating your own memory, checking for null pointers and things like that in C, or in Python rather. You don't have to worry about checking those things, but in C you definitely have to worry about that. Similarly in C, because those are things you do have to worry about, those are essentially lines of code that you can omit if you're translating from, say, C to Python. So there's things like that where you kind of have to understand what the code is doing in order to properly translate it. So if you're doing it correctly, you can essentially identify bugs in the code, if there are any, and be able to fix those. And then it kind of goes back to the point of, okay, so you ended up fixing issues with the old version, when making the new version, so you literally just made the old version better. Why did you make the new version? So there's still arguments to be made, but again, we can go back to that argument of 70% of all bugs, being memory safety related. But kind of getting back into the article, though, what's also interesting from the article from the Register, which is where I'm pulling this from, that I'll have linked in the show notes below, is they mention the CEO of Code Metal, which is, I guess, a company that raised $16.5 million. And essentially what they do is focus on translating code for edge hardware. And the CEO there basically mentioned that he wasn't ready to write off C and C++ yet, which, I mean, I think even the that report or the not executive order, that press release or whatever that the White House put out a few months ago, encouraging the industry to switch to memory safe languages, kind of also even admitted that there might still be some use cases for, C and C++. But also, we should also mention that he also went on to say he thinks that, of course, I think all languages, he says, quote here, I think all languages are about trade-offs, but certainly at the kernel level, it makes sense to move part of the code to Rust, end quote. Now, the guy overseeing the project at DARPA even admits the shortcomings of LLMs, which we kind of already discussed, saying, quote, LLMs can give surprisingly good answers when you ask them to translate code, but they can also hallucinate incorrect answers, end quote, which, yeah, I mean, that's kind of all the more reason why if you are planning on using, machine learning or artificial intelligence, you better ensure that you have total test coverage of the code base to make sure it didn't mess anything up. Which honestly, if you're getting, in all reality, if you're getting an AI to translate your entire code base for you, you're probably going to have to work through a good number of compiler errors before you can even get to running test cases, if we're being completely honest with ourselves here. But anyway, but in fairness, even a human translating code from one language to another, you're still going to run into compiler issues. So that's not necessarily something specific to if an AI did it. But again, depending on how large your code base is, that would be an absolute chore, essentially, to translate the entire code base, even if you're using AI to automate things. And another issue with translating, C into Rust is the things that C allows you to do that Rust forbids, which I think we talked about this on a previous episode before. But there are ways you can kind of get around this in Rust with things like the unsafe keyword. But then again, at the end of the day, what did you really achieve by doing that? And to get back to the CEO of Code Metal's point that he's not ready to write off C and C++ yet, one of the most powerful things that C and C++ allow you to do is have physical access to components of the system, like memory, for instance. So one of the probably best examples of this is if you're working on embedded systems, for instance. Sometimes in order to program them properly and get the input and output you expect, you need to access specific memory addresses in the system's physical memory in order to set things like what's being displayed on the graphics, play certain sounds, get input from the device, things like that. And the only way you can do that is, like I said, accessing the physical memory addresses, by, specifically having pointers to those memory addresses, which is something you're really not allowed to do in Rust unless you do, like I said, the unsafe keyword. So one specific example is if we take the Game Boy, for instance. The Game Boy, in order to identify which buttons the user pressed or draw graphics to the screen or play sounds or things like that, you need to access specific memory addresses and, do things like offsets and things like that in order to identify, the buttons that were pressed to display graphics to the screen, to set what graphics mode you're in. So all kinds of things like that. You need to access the physical memory addresses in order to do that, which is something that C allows you to do quite easily. Another thing that we should also probably keep in mind here with memory safe languages is just because a programming language is memory safe does not mean it's safe from all vulnerabilities, right? Like as mentioned numerous times through this episode, that, statistic of 70% of, bugs are memory safety related issues, which still leaves 30% of the bugs out there not being memory safety related. And of course, these are bugs like your common logic errors, like you forgot to add one, or you didn't wrap around to the beginning and you just kept going off, which could potentially be a memory safety issue. But, you're kind of off by one errors, things like SQL injections where you don't parse the user input properly. Things like this are still possible even in memory safety languages like Rust or Go or Swift. So to recap here, since we've kind of been going on for a little bit now, nothing has been developed yet, right? So this plan by DARPA, this tractor, it's only a plan. There's been no actual development on it. It's essentially just a research project that they're planning to work on. So nothing has actually been developed yet. There is currently no AI developed by DARPA at this point in time that translates C into Rust. It's all essentially an idea. Now, kind of getting into that of translating code from one language to another, just to recap, it has several issues. One being you can introduce new bugs into the code base, into the new version you're translating into. Two, you can copy existing bugs from the old code base into the new code base. And three, you also lose any kind of pedigree or resiliency with the new translated version, because you're essentially creating a brand new project in essence that has never been tested, compared to, the C version might have some potential memory issues, but it's also been tested in the wild to be fairly bulletproof. So whatever new version you create, you essentially have to show that it's just as bulletproof and just as resilient as the legacy version that's been, kicking butt and taking names for however many years it's been in production, right? So that's another kind of big thing that I don't think necessarily gets talked about when it comes to translating code bases, is that resiliency and reliability that the legacy code bases have. Because as much of a pain as they might be to work on and all the technical debt that comes with them, one thing that can't be denied is how resilient they are, being in production for however many years they've been doing that. So to essentially create in essence, a brand new project, because you're completely rewriting the whole thing, you lose all that history of being a very resilient and bulletproof piece of software. So you essentially have to reprove that. Now, again, like as we mentioned, a super robust suite of test cases can help build the case for it, but it's not like, the full stamp of approval. It, passed all the test cases that we have. It's, just as good as the old version. You kind of got to, build up to that, right? You got to have that experience and resiliency of being in production and being bulletproof, just like the old version, before you can, give it the final stamp of approval and say this was a full success. So I guess, for me, my final thoughts on this is I think it's quite honestly a very noble goal, to translate code from memory unsafe languages to memory safe languages, because if you can do it in an automated fashion, it removes a lot of the headache and manual process of a software developer having to translate that code. So if you can automate the majority of that process, it will definitely save you a lot of time. But with the current state of AI right now, I'm just not convinced that the AI is going to be able to translate code bases without a serious level of human intervention and hand-holding and testing to ensure that it was actually done properly. So yeah, those are kind of my main thoughts. I think it's in the future. I think it's definitely probably a solid possibility. Just right now, I don't think AI is quite there yet. But I definitely do think that it is something that could potentially be a viable solution, maybe in the future. But what are your thoughts on this? I'd be definitely interested to hear what you think about, all this DARPA stuff, using AI to translate code from, C to Rust or from any language to another one. If you've had any experience with this, I'd also be interested to hear that. So if you're on YouTube, you can leave a comment down below, or you can also shoot me an email at contact@darkassassinsinc.com. I'd be interested to hear your thoughts on this. But before we wrap up for the day, let's get back to our trivia question, which is, in computing, the BIOS is firmware used to provide runtime services for operating systems and programs to perform hardware initialization during the boot process. But what does BIOS stand for? If you said Basic Input-Output System, congratulations, you got this week's trivia question correct. Hopefully, some of you got it. I know BIOS has been a word that's been out there a lot, so maybe it rung a bell, and if it didn't, well, now you know what BIOS stands for. So again, to wrap this episode up, if you enjoyed it, definitely be sure to leave it a rating and review and subscribe if you haven't done so already. And there was a lot we talked about in here, from, translating code to test cases to creating memory allocators for debugging purposes. So if you think you know anyone that might find benefit in that, definitely share this episode with them, or any other friends and family members that you might have. And if you have any questions about this episode, or have any comments or questions or topics for future episodes, shoot me an email at contact@darkassassinsinc.com, or you can leave a comment down below if you're on YouTube. And that's going to do it for me in this episode of the Dark Assassins podcast. Until next time, my fellow assassins, remember, bool nothing equals true. If action not equal to null, return true. I'll see you next time on the Dark Assassins podcast.